The remainder theorem is very important. It helps us sometimes so we don't even have to divide and we can tell if something's a factor. So with the remainder theorem, you take the 0. So notice this used to be a plus 4. So if you take the 0, you got a minus 4, minus 4. You take the 0. Okay, that's super important. But you take the 0, and then you plug it in to the actual function. And if you remember, the output or the answer that we get will be what the remainder would be if we were to divide. So we know it's a factor, we know it's a 0, we know it's a root. If we plug in the value and we get, if we get 0, 0 is kind of the goal there. So let me pull out my calculator real quick for some of these. I don't really want to do them in my head. But 4 to the 4th, I know 4 to the 3rd is 64. So 4 to the 4th is 256. Negative times negative will be positive, so 256. And then 64 times 8, but it will stay negative. So, because negative times a negative times a negative is negative. So negative 512 is what I get there. And then 11 times 16 is 176. That changes or stays positive because the negative times a negative becomes positive. Here again, negative times a negative becomes a positive. 18 times 4 is 72 minus 2. So I'm going to take care of that. 256 minus 512 gives me negative 256. Then when I add 176, I get negative 80. Plus 72 is negative 8, minus 2 gives me negative 10. So basically, if I were to have divided a plus 4 into this polynomial, the remainder would have been negative 10, which just helps me know that, hey, negative 4 is not a root. It's not a 0. It's not a solution. All right? But that would have been the remainder.